for the research grant, which you can read on your own. It's quite long and kind of cumbersome. Basically, it just says that we're going to be using a simple microcontroller to create low-cost robotic solutions that we have displayed here for both student projects and hobbyists alike, in the hopes of teaching other people how to use robotic technology. Okay, and this is the symbol for our project. We renamed it to RoboTut because it's a lot shorter, it's a lot easier to say, and Seth drew up this catchy little symbol for it, which was an R and T put together. So it symbolizes our project well. Thanks, Seth. So the overview of the project is, first of all, I'm going to go over the reason that we actually went about this project, how we went about this project. Finally, each person is going to individually talk about their robots, what it does, what it should do, some problems they have with it, and then we're just going to bring it back to the conclusion. Okay. So the reasons we actually did this project, there are a few of them. Basically, we all love technology, we love working with robots and computers, and we're big nerds. So this project was a really easy decision for us. We had a lot of ideas of what we wanted to do, but we really wanted to work with hardware. And we didn't just want to work with hardware for ourselves. We wanted to try and help other people learn about how to use hardware as well. So we figured the best way to do this would be to build these simple robots. We're going to put up a site that features tutorials, which we're putting up now, video tutorials on exactly what we did and what we went through. And hopefully through our experiences and what we put together here, we can teach other people exactly what we did. Some of the problems with a lot of the robotic solutions out there today is if you want to try and build a robot, they're going to try and tell you, pick microcontroller, it's expensive, it's like $100, it runs basic, you're going to have spaghetti code because it's lots of go-tos and jump statements, so it's a big problem. What we did is, slide. Okay, actually go back. We actually use the Arduino, which I'll talk about in a little bit then. Some of the other solutions we looked at, first we looked at the iRobot Create, which Vinny had used, as well as Brian, and we thought it was a little too expensive, especially once you factored in the controller board. Our entire controllers were only $32 for the entire controller umbrella. It was $50 for the other controller for the iRobot Create. Also, instead of buying more expensive sensors or being stuck with the sensors that were in the Create, we could just get very cheap sensors and just integrate them into our robots. And then finally, the microcontrollers were once again cheap. Okay, our original plan was that we were going to create 2 autonomous robots, and we're going to use a variety of sensors on both of them, so we have a few demos per robot, and we could really show what the capabilities of the Arduino and the sensors were. We're going to write up the video documentation and the website, and then we decided that we were going to use the Arduino microcontroller. This is the Arduino. Basically, it is an ADR 8-bit microcontroller which runs RISC assembly, which if any of you have taken assembly here, we use Spark. Very similar. There's a few differences. A lot of it that's different between the chips is actually on the chip-to-chip basis. The different models have different instructions for different jumps in memory. The nice thing, next slide, is that we didn't actually have to worry about any jumping. We didn't have to do any bit flipping. The API that comes with it is all C level. Basically, if we want to write something high to a pin, we just have to say digital write high, and that'll do exactly what we want it to. No bit masks, no bit flipping. It's very nice, it's very easy to use, and it's very nice for people who've been programming in C and C++ for years because they feel very comfortable in this environment. And the code is very readable. They're going to show you their code once they come up, and it's just C code that is very easy to use. Next slide, please. Basically, we went about this by hooking up.
I forgot. Okay. Keep going. I'll get it.
Okay. So basically what we did is we took a computer, we hook it up to the Arduino using a USB port. There's actually a serial over USB connection. We'll program the chip. It'll run, in a sense, just the RC cards that we bought. And they'll be the data will come back from the sensors that we have to the Arduino, makes the cars run, and controls their behavior. Next one. And basically what we want to do in the end is completely cut the computer out of the loop. We have them running autonomously. At this point we have 2 of the robots pretty much fully working autonomously, and they will move on their own. There's no computer involved, it's all just the Arduino. And once we got into the project, we realized that we were going to have to modify our plan. Our original plan was just the 2 robots, but we figured since we have 5 people, we could have at least 4 people doing robots, and then I could be helping each person individually. And this would give us a wider range of demos for what we could be doing. So each robot is to generate areas to use specific sensors to have different effects. And that's going to leave it off to Mark then.